In this problem, we are going to look into the function behavior, into transformations, and we will graph it by hand. So we have a function given to us. We need to identify 3 key points on the graph, calculate x and y intercepts. Those are actually going to be our two key points. We will be using interval notation, domain and range, for the domain and range, and then we will have to explain the transformation effects on the function. So we have for the 3 key points. Again, we have 2 key points. Those are our x and y intercepts, and probably that's going to be 3 key points already. And maybe the vertex. We can see this is the polynomial. So on the left here, I'm going to plug in some numbers and see if I can figure out what the values of the function are. They're going to be helpful. And then we're going to graph this. So let's start with x equals 0. If you plug in 0 in here, you just have 1/2 times -5 quantity squared minus 3. -5 squared, that's going to give you 25. 25 times 1/2, that's 25 over 2. And then you're subtracting 3, which can be written down as 6 over 2. 25 minus 6, that is 19 over 2, which is 9.5, right? So that's what I'm going to write down, 19 over 2. Or I can write down 9 and 1/2. So that is the point right here. It's kind of hard to tell. Over there. All right, so then in a similar manner, I can calculate g of x when x equals 1. It's going to be equal 3 over 2. When x equals 2, it's going to be -5 over 2. And then I also did 2.5, so then it's going to be a -3. We can also do 4, and then we will actually see that the value of g of x is going to be 3 over 2 as well. So let's sketch those points and see what's happening. Well, for once, we can see that 2.5 -3, that is going to be a vertex. So somewhere over here, that's the vertex. And then we have 1 and 3 over 2. So that's the point here. And then 4, 3 over 2. That's also the point over here. And then for 2, it's going to be -5 over 2. So that's -2.5. And then we will have another symmetrical point somewhere there. So we can already see how the parabola is going to go. And then over here, we have a point there. So let me try to graph it. All right, so this is the parabola that we get after we plot the points and try to connect them together. Now let's calculate x-intercepts, and then we are going to try and calculate the y-intercept. Well, actually, we already did y-intercept, so I'm going to start with that. Once I'm done erasing. So y-intercept is when x equals 0, right? So x equals 0, that means that the y-intercept is 0 and then 19 over 2. And 19 over 2 is our exact value, approximate value. We can round it up to, we can convert it to decimals and have 9.5. It's still kind of like an exact value. So there is no exact and approximate here because we don't have any non-terminating decimal. We don't have any irrational numbers. All right, for x-intercepts, we have to set up g of x equals 0. In other words, we are solving a quadratic equation 1/2 times 2x minus 5 quantity squared minus 3 equals 0, which means we bring 3 to the right side. So we have 1/2 2x minus 5 quantity squared equals 3. Then we are going to multiply both sides by 2, opposite of 1/2, right? So 2x minus 5 squared equals 6. Take the square root of both sides. Remember the plus or minus in front of the square root of 6. So here is our exact value. And then we will have to add 5. So 5 plus or minus square root of 6, and the final touch we divide by 2, so x equals 5 plus or minus square root of 6 over 2. We can plug those values on in the calculator, and then we can get the approximate values for x-intercepts. Those values are 1.275 and 3.275. So that is 1.2 and then 3.2. sorry, it's 3.725, not 275, 725. The other way around. Okay, 725. All right, so those are our x-intercepts over here and over here. So to label them correctly, we would have to say 1.275 comma 0 and 3.725 comma 0. So those are our x-intercepts. All right, for the domain, since we need to use the interval notation, we would just write down that the domain is from negative infinity to positive infinity. The range goes from the lowest number up. The lowest number was when x was equal negative 2.5, y was equal negative 3. Negative 3 is the part of the graph, so we put the brackets here, and then the graph opens up, so all the y values keep on going up to the infinity. Okay, so that's the range. We need to label, where does it say? Provide the coordinates for at least 3 key points on each graph. So I can label this point and say that it is 2.5 comma negative 3. I can provide the coordinate for the y-intercept, which was 0 and 19 over 2. And then I'm just going to label, say, this point, which was 3.725 comma 0. Right, so I labeled 3 points, and then I can also label this one, but it doesn't fit that well anymore. Okay, finally, we need to explain which transformation effects are being applied to the parent function and the order in which they are applied. So let's take a look at that part next. For the transformations, I plotted here this red parabola. So the red one is just a parent function, it's x squared. So then let's take a look at what's happening. We are going to follow the order of operations. So first thing, this 2x. What it does is it shrinks our function horizontally, so it kind of like squishes it from the side, right? So even though it says 2, that means it's twice as skinny as it was originally. So I have a couple of parabolas here. Let's play with this one. So it looks just like the original one, and then now I have to squish it twice as much. So when I had the coordinate for the red parabola, I had coordinate, for example, negative 2, 4. Now I'm looking for the coordinate negative 1, 4. So I need my parabola to go through those points, negative 1, 4. Okay, it's kind of hard to tell right now. So over here and over here. So I'm going to use a different one. Let me write it down. So I started with the point negative 2, 4 for the regular parabola, right? Now I squished it, so now it becomes negative 1, 4. The next thing I'm going to do is I'm going to shift it to the right, and it looks like I'm shifting it to the right 5 units. But here's the thing. If you factor out this 2, you will have x minus 5 over 2. So actually, I'm shifting it to the right only 2.5 units, 5 over 2. And then I'm still having my squished parabola, and I'm moving it to the right. So let me try to do this one. And I'm moving at 2.5. So see how the vertex, oh, okay, over here is at 2.5. My dog is here and he is kind of unhappy with me. He wants to go for a walk, so he is distracting me right now. Okay, so we have this parabola, very skinny like this. Okay, so we shifted it, this blue one. So we shifted it to the right by 5 over 2. So now instead of a point negative 1, 4, right, it was this point over here. I shifted it 2 over 5, 2.5. So now it is going to be 1.5 comma 4, right? So I'm adding 2.5. So now it should be 1.5 comma 4. So it looks like I'm a little bit off, and I don't know if I can move this parabola. Yeah, I cannot move this parabola. So this blue parabola actually should be going, the vertex should be somewhere, it should be over here. And then the point that I'm talking about should be 1.5 comma 4, so it should be over here. And then the other point should be over there. Okay, Next step, we need to multiply by 1/2. So now we are shrinking it vertically by 1/2. So it's a vertical shrink by 1/2, which means that now we're going to be multiplying our y coordinate by 1/2. So our point now becomes 1.5 comma 2, and our parabola is going to look somewhat like this. Parabola. So 1.5, let me see if I can do it properly. Okay. So it should be at 1.5 comma 2, and the vertex is at 2.5, right? So that's the point that I'm talking about, 1.5 comma 2. So this point, this is where it was, and now I need to bring that point down. So it is 1.5 comma 2. So it's actually going to get a little bit wider than it was originally. So see 1.5 comma 2, like somewhere here. So that's the point right there. Okay, so maybe a little bit wider, a little bit wider. And then the center is at 2.5, the vertex is at 2.5. So that is the new parabola. And then final touch, I have to bring that parabola 3 units down. So that is how I'm going to get this original shape. I'm not going to do that anymore. So that is my last step. So my point, the one that I took originally, becomes 1.5, and then 2 minus 3 is going to be -1. And that is what we saw here. We had 1.5, -1, that was this point right there. I erased the numbers here, but if you go back and then you will rewatch the video, you will see that that is exactly the point that we got. And then final step here is to write g of x in terms of f of x. So what did we do with f of x? We said that we did 1/2, okay, 1/2 f of, since instead of x squared we have 2x minus 5, I would have to write down 2x minus 5 quantity squared, and oh sorry, f of x minus 2x minus 5, no square here because f of x is just 2x minus 5, and then minus 3. So that is my function g of x in terms of f of x, right? And actually it's not going to be just f of x, it's going to be f of 2x minus 5 because I have to plug it in here. And that's our problem. That's it.